Good morning, team. Good morning, Gobi and Peter.
Good morning. How are you today?
Good, good. How are you?
Yeah, just fine. Well, it's obviously not morning. I'm sitting here in Sweden, but late afternoon, and that is fine as well.
Welcome to the group. We not probably met before. So you're from university?
Yes.
Okay,
I,
okay.
I used to be pretty active in this group during last summer,
Okay.
uh, and then I became the head of a work stream for heat reuse economics, and so I was sort of branched into the heat reuse work streams, or several of them, like policies as well, with Jamie Comella.
Oh, good, good. Okay, okay.
So,
So
but
welcome
but
back. Yeah.
yeah, but I noticed that there is now a white paper on PUE coming up, and since I've been writing about metrics myself, it's part of my PhD thesis on data
Okay.
center. I thought I could pitch in and listen, and
Oh,
perhaps read through the document if desired.
yeah, yeah. So yeah, we can give you the access. Probably if you can send me yeah, Google uh, mail or the access. I think sometimes the OCP, the share folder does not allow all the accesses.
True.
Your Gmail or OCP email address, send me, then I can give you access. Do you
Mhm.
have a OCP project ID?
Or can I just send it in chat? Oh, I can send it to you in the chat.
Yeah, yeah. You can send it me.
I can send it anyway in the chat.
Okay, okay. Good morning, Srithin. Good morning, David.
Good morning.
Good morning, Eric.
Morning.
How are you folks doing?
Good, good. So I think we can get started. I believe we have quorum here. Um, any opens before we can get started today? If not, I think the first item I would like to close on is the white paper. Is there any additional comments, or are we good to send it to the project leads for final review before we can say that we can post it?
I think we're ready for final review.
Okay. Yeah, I tried to include all the comments I had. So I don't have any pending items to be addressed on that paper yet. If not, I think what I will do is by Monday I send it to the project leads, sustainability leads, and I would like to get the final review before we can ask them to post it. And the second topic I would like to close is the one we are discussing on the IUE, whether we want to have the percentage or the number 0 to 1. Let me bring the slides, what I'm trying to talk here. Do you see the presentation?
Yep.
I see it now.
Coming through.
Yes.
Okay. Okay. I think let me go to the main portion of it. Yeah, thank you, Eric and Shruti, providing the comment. I will have to address it before we go to the final one. So when we are talking about this can be applicable for either a rack as well as a DC side. So in IUE, what we are saying is the top side, we are going to have the computational power, and the bottom is active server power. So the maximum value is going to be 0 to 1. So if you have a, there's no computational power, basically the system is sitting in idle, you're going to get a 0. If you have a 100% compute and all the active server power is consumed with compute, you will get 1. So maximum value is 1. And if you look at PUE, it's a minimum value is 1. So you can go from 1 to infinity, right?
Yeah, this
But,
is basically the way you do an efficiency.
correct.
You're calculating the percent of power that you're deeming to be useful.
Correct. I think my question is, do we want to multiply by 100 and say it's 0 to 100, or we want to keep it 0 to 1?
Well, yeah. So the big question, I guess, what I had envisioned was something that we could use as an IT side standalone metric, and then combine with PUE to get a total. Right.
Right.
And so we would want it to be done the same way that PUE does. Now, we could define it to be used with DCIE instead of PUE, right? The reciprocal of PUE is an efficiency score.
Yeah, so for DC level, I do have the formula here, Eric. So PUE, we are calculating at DC level. We could potentially go for a system level PUE.
Yeah, but now you're we don't want to modify PUE. I think PUE's been around long enough. We should leave it alone, right? If we want to define some term for the product of PUE and IUE, we could do that, right?
Right.
But then we have to define it in a way that you can combine them together somehow to get a total, right? And the easiest thing to do, I think, would be to define IUE the same way that PUE is done, as an effectiveness, not an efficiency. So a number whose minimum is 1 and not a number whose maximum is 1.
Yeah, we can basically say it's 1 by IUE is efficiency, effectiveness, not efficiency, right?
Right. And the way to do that would be to take I guess what you're worried about, right, is a divide by 0, right?
Correct.
The theory that if your system is sitting idle, then idle plus overhead over idle is a divide by 0 problem, or idle plus useful over useful when there's no useful power is a problem, right?
Correct. And at least system level, like I don't know whether data center level is going to be sitting in idle, right? So I think system level, when you do divide by 0 is mostly possible, right?
So on that comment, Eric, I don't exactly see, I mean, it will be good to have both these metrics in a similar form, that I agree, but I don't exactly see where we would want to add them together. Like, I think that would not really, like, what does the added form of that convey?
No, not added a product, right? You multiply them together to get a total efficiency or a total effectiveness, right? You can imagine if you had watts per useful work, right, on the IT side, and then you have IT watts over total watts, you can combine them together to get useful work per total watt, right? That's a useful thing to think about.
Okay, maybe product makes
Right.
product makes better sense. I need to
product
think about that a little more. Okay. But yeah, I think I agree with that point that maybe we want to have it in terms similar to PUE then.
So I think the problem is how do we deal with the divided by zero, right?
Right.
So because in system level, you will run into the situations, your system is sitting in idle, so you will have a divided by zero, infinity. If you basically it's nothing but effectiveness is nothing but 1 divided by system IUE, right? And even PUE, if you want to say efficiency, it's 1 by PUE's efficiency. Or 1 by PUE into 100. Right?
Yeah, if you do the reciprocal of PUE, you can define that actually is defined as data center infrastructure efficiency, I think DCIE.
Yeah, DCE, yeah. Mm-hmm.
And if we could define that as the thing that you want to make a product with and get a total efficiency score, right? That gets us away from the divide by zero problem.
Correct.
So we are landing upon this divide by zero problem because we are looking to do a product of the two.
No. We have this problem if we try to do an effectiveness instead of an efficiency. If you go back to the PUE formula.
Yeah, but the reason we would be doing an effectiveness instead of the formula the way it was written is to be able to do the product, right? Otherwise, it anyways conveys what it conveys.
It can convey what it conveys either way, right? As an efficiency or an effectiveness, right?
Right. The only reason we would want to switch it is if we do want to do the product with PUE.
Right. Yeah. If we want to do a straight product and end up with a number in the same style as PUE. Now,
right. So
we could combine it with DCIE and then flip it over to get a total effectiveness anyway, right?
Yeah. Mm-hmm.
If we wanted to, right? I think that what we're up against here is just if the system is idle for the entire reporting period, what do you report? Right.
Right. So I'm sort of coming to the point that it looks like whether we want to invert it or not depends upon whether we want a product or not. Like, is the product a meaningful thing that we are going to convey should be, calculated and presented?
I think the team we started was, right? The PUE is not even though it's been used for decades, is not a complete representation as many losses and other things are not taken into account. And then a lot of decoupling of the components. That's the reason we said, hey, IUE is a better metric. That way you can go to unit level in a way, right? So that was the thinking. Even though active server power is zero, is not zero, it's that there is something, right, being consumed. So we should not literally take it as zero, right?
No. What I mean to say is the active power, server power always going to be greater than zero.
Right.
The computational power is, if the system is sitting idle, we are saying computational power is zero, right? It's nothing CPUs are consuming, no really services are produced, right? So if you flip it, then it will be divided by zero.
Yeah, agreed.
Right. So that's why I think, can we use a efficiency rather than effectiveness? Or if you want to, I think the question is for E, what do you want to use, right? You want to use efficiency or effectiveness?
I think to me, effectiveness is, works fine, but I'm open, right? If others have different view.
Yeah, I think where I'm heading is we can leave it as an efficiency and then use that terminology, be consistent about it. And that'll get us away from the divide by zero or any, the case where there's no non-idle power. Right. And then the reason that I'm interested in combining it, right, is just because you have the work per IT watt and then the work per total data center watt. I think those are both useful metrics. So it seems like a good idea to define a way to combine them.
Okay.
You
Combining
feel
basically you mean is product of IUE becomes some PUE, right?
Yeah, well, the other thing we could do is, but we could do all of this in a, you know, if PUE had been, you know, defined by the engineers, right, the geek squad instead of the political squad, it would be an efficiency anyway, right?
Right.
A number where the minimum is 1, and you have to like do gymnastics to figure out what the efficiency is. It never made any sense. It caught on and got traction, and it's been going for 15 years. So, I mean, I wouldn't try to mess with it now,
Right.
but I think the idea of, you know, a total efficiency for at a data center level is something that we're probably going to contend with, because I think there's going to be some minimum efficiency standards set through regulatory means eventually. Right, maybe in Germany
Right.
first, but someday that'll get here too.
If we are going to use efficiency as a metrics, then going with 0 to 1 or 0 to 100 makes really sense, right?
Right, yeah. Efficiency
Right.
is just defined as a percent with a maximum 100, right?
Right.
That's you know, everybody learned that in school, right? A long time ago. No matter what you use it for, right? Effectiveness is a weird concept by contrast, right? But but there is all we would do, we'd leave it the way you have it defined, but we try to get rid of any interchange between effectiveness and efficiency, and always use a term efficiency, right?
Right.
So
Okay.
it's unambiguous what we're doing, and then we would, when you combine it for a total efficiency, you'd have to combine it with the reciprocal of PUE, not with PUE as is, right? The other thing you do is just divide by PUE instead of multiplying, right?
Right. Yeah. I think I could probably make a clearly on a slide to kind of state the
Yeah, well,
things that
your
makes
picture
it
where you
clear.
have both of them
Right.
makes it pretty clear already. It's just a matter of how
Right.
you speak to that picture.
Okay.
Can
But
I
I
add something?
was
Oh,
just
sorry.
dissatisfied with the language of IUE just further subdividing, right? What IUE is about is to capture or characterize the efficiency on the IT side. PUE just assumes all IT power is good power. We're making it clear that that is not true.
Correct.
We want to characterize how much of IT power is good power.
Correct.
Yeah. Can I just clarify one thing there? When Eric speaks of Eric, when you speak of work per watt, basically, I mean it's not really what this is either. It's a computational power. I mean, we have a CERT and flops and so on for that.
Correct.
So there is a bit of a difference there. For example, you have like administrative routines. They will also go into this, as I see it, but that is not really doing any useful work, of course.
That's fair. That's fair. Yeah, no, I was just saying we're characterizing which watts we want to use, right?
Yeah.
So
Yeah.
there's you know, work per total watt and work per useful watt, right?
Mm-hmm.
Once we define what work is, yeah, that's fair.
Mm-hmm.
Okay. I think it was from the performance side, we said like we need to come back and work towards
Yeah, we need to
how
come
are
back
we going to
to
define,
what
right? Yeah.
performance means for sure. Yeah.
Correct. Yeah.
Yeah,
A
because
future-
data center anyway is heterogeneous workload. So, you know, just we want to see, does it make sense when you compare data center 1 to 2 to 3 and beyond, you know, what it is, you know, right? So that'll be quite challenging.
Yeah, I think the challenge, Gopi, is that we're already in the Green Deal Energy Efficiency Directive in the EU,
Mm-hmm.
right? They're already asking this year to start reporting the capacity of the data center and its utilization.
Mm-hmm. Yeah. Mm-hmm.
Now, they haven't provided much help in what that means. but
I know, it's just
and you're right that the data centers typically, I mean, some of them are homogenous, but not very many of them, right? You
right.
can
Yeah.
find a
Yeah.
dedicated AI training data center, a dedicated HPC data center.
Right. Yeah.
But otherwise, you know, pretty much every data center that's doing useful work for a company has got, you know, storage and network and compute at a minimum, and probably more than one flavor of compute. So giving it a capacity that's measured by a compute proxy is a little weird. right?
Yeah,
For
definitely.
all of the infrastructure, some of which doesn't run compute proxies or doesn't run anything that the compute proxy is trying to estimate anyway.
Right. Yeah.
Yeah. So that's a whole different headache that we'll have to worry about.
Oh, yeah, definitely. I mean, if you take a class of application like HPC, hey, I have 1024 nodes, then if you compute, all the metrics associated that, then it gives a more meaningful compared to taking a whole bunch of heterogeneous and say, oh, I'm going to give here is the useful work. How do you compute, right? So it just kind of gets weird, right? That's all,
Yeah. We'll come to grips with that on a different day.
Yeah. Yeah, I agree. Sure. Yeah.
Then the other one is here, right? Using IUE, you want to do the, I think this is not sticking. Okay, I will fix it. The rack level, again, we are saying it's a sum of all the servers computational power divided by all the servers active power. And we can represent another way. You can use IUE of each server. If you know, then you're just multiplying by active power of the
This
server.
might be problematic, right? On the right, the problem is that the middle one and the right one may not match. If there's a non-compute system in the rack, right? Like a networking switch.
Yeah, but it's you're going to say it's consuming the whole power, right? So it's going to be on anyway. So if you're not removing these losses, what you're saying is even network or storage or anything, it's 100% consuming there, right?
Can you try that again? So you'd say you'd.
So computational does not mean only CPU. It can be network, it can be storage. It's you can basically think of it.
If that's what we're trying to do, then we're going to have to provide an example of numbers for non-compute servers, I think. Like if you drew a rack, right?
Right, yeah.
Typically going to have two of the enclosures, two of the rack mounted units are going to be dedicated networking switches, right? Which do have a control plane processor in them, but arguably they're not running any user workloads, right?
Right.
And their power doesn't probably move much, right? Irrespective of port utilization, you're probably within 15% of peak active power all the time on the switches, right? The way switches are built today, anyway.
Right.
And then you have compute servers with or without storage devices, with or without accelerators, right? And I think applying this to a compute server is obvious, and even though it's implicit versus explicit, right? If we're going to apply this same metric to a switch, I think we better be explicit about that. I hadn't really thought about it.
Yeah, I was basically maybe I think instead of using compute power, you should say the IT power. That's what I was really meaning here, right? Real IT, non-IT.
Yeah. And so
and
maybe
the compute can include
talk
switches and network,
further
right?
about that nomenclature.
Right.
Right. Device power, useful power, or something other than computational.
Correct.
Network is included in this in a way. Right?
Correct.
Yeah,
well,
definitely.
Yeah, on the bottom right, if you look at the formulas in purple on the bottom, right? The switch is certainly in the total rack power, or it should be.
Right.
It seems like that's unambiguous. Whether you have any server computational power in a switch is not clear at all.
Yeah, where the computational power kind of throws out, right? It's basically we are meaning real IT power, non-IT power, right? Or if we take a rack, if you have compute, CPU versus network plus storage, we want to combine the real compute done and also any network related to that used and storage related to the used as part of the compute. But anything related to the losses like thermal power and idle, we want to remove it, right?
Yeah, I think yeah, that makes sense. I think obviously we don't want to blind forwarding of packets with no processing. I don't think we want to call that processing. Right. But
right. What is the term will be a better term instead of saying compute power? Is it some different term we want to be using?
Yeah, it seems like we want to talk about the real trick is the idle power element, right? How do you apply an idle power element to a switch? I'm trying to think of how you would measure this, right? What's the telemetry that's missing from switches today? Do we want to go try to establish an OCP standard profile where you have to be able to break out the split of the underlying non-useful power associated with the switch versus the useful power of the switch? This is starting to get a little tricky, right?
Switches generally won't be sitting in idle, right? It's idle for that is you could
Yeah,
say zero, right?
but it's not, right? I mean, because of the fives, right? 60% of the switch power is the fives, right?
Oh, right, yeah.
And the fives are up when there are no packets being slung by, just because the links are up and they're trained, but no one's sending any data other than whatever network maintenance traffic is, right? That's idle in a switch, right?
Right.
Yeah, I think trying to generate this metric for a switch seems problematic to me, but I haven't really thought about it until right now, so it's probably worth further thought.
Yeah, we had a discussion a long time back. Hey, can we use a number of bytes transferred with some metrics, right?
Yeah. And the problem with that is that the maximum efficiency, if you utilize bytes versus unutilized bytes, right, or utilize actual transmitted data per watt, I don't think you're ever going to get an efficiency higher than 15 or 20% for a switch, because the power is not particularly proportional to how much good put or throughput you have on the links.
Yeah, I think we could table it for now, and let's when we define this ideal power for switch, that need to really call out what is that need to measure. But as a concept, we can still
table
have
it
it.
as long as you don't try to include this example in a rack.
Right.
Speaking of idle, in your former slide, you also had idle power on. If you could go back to that, please. Yeah, thank you. I'm thinking what you want to do here is to basically do like PUE. I understand it. So you have IT versus non-IT or so. But if idle power, maybe it's a language thing, but idle power for me is when it's not doing anything. And so you can't really have computational power on one hand and of the scale, and then idle power at the other part, because they are not simultaneous. Maybe I misunderstand something.
So this is a graph you want to kind of look at it, right? System goes to idle before you start priming any workload on it, right? When you are sitting in idle, power is consumed. No useful work is done. So we want to count that as non-IT, right?
Yeah, this is an interesting philosophical question, Peter. I think, do you pronounce your name Peter or Petter?
Petter, yeah.
Petter, sorry, yeah, it's kind of maybe a name. My last name's Dahlin, or it should be.
Yes, Erik Dahlén in Swedish. Yes.
A few generations ago, someone bastardized it. We pronounce it Dalen, but but yes, it's a Norwegian name. So this is something that Meta, in helping propose a metric of this nature, is kind of already doing this, right? Where idle doesn't mean in a sleep state. Idle means ready for work. right? So the cloud platform is loaded, right? There are hundreds of network ports open, right? And it's part of the load balancing pool, and the orchestrator and the management devices are pinging it to make sure the server is in a good state and responsive. But you haven't load balanced any work onto it yet. And what they were doing was so it's got the cloud platform running, it doesn't have any cloud workloads yet. It's not delivering any services yet. And when they do updates to their cloud platform software, you can imagine anything that's part of the load balanced cloud fleet is going to behave this way. It has this kind of a nature where you can get it all ready for work, and then you can start giving it work. And in the ready for work state, it's not idle, and they're actually approving or rejecting releases based on their impact to the idle power of the platform. because this y-intercept really matters in terms of what your average power really is, right? At any given load. And so we wanted to kind of factor that in somehow. But this whole concept, right? This slide, tries to make clear why we care about idle power. And idle power doesn't scale with load, but everything else does, right? It was the other challenge here, right? The thermal overhead and the power delivery losses overheads, those scale with load. If you increase the power, you increase the losses. If you increase the power of the server, you increase the fan power too. And so the metric makes sense if you're thinking about a compute server that has a load line that looks like this, right? This is where I wrapped around the axle trying to apply this to a switch. Right?
Sorry, one quick thing. I was just asking that the idle power and active power are not measured at the same time. I mean, don't happen at the same time. And that is right. They may be measured at different times for this calculation.
Yes.
Is that what you wanted?
Yeah, you can't measure the idle power when you're active, but the idle power is still there.
So it's not measured at the same time.
It's, I think what we said is while during boot, you can probably do a dynamic measurement, or if the system builder can say like, hey, you already measured, and they can just pick it as a static number, right?
Yeah, this is an interesting point, right? In that part of how to resolve this and decide if we're happy with idle power and its inclusion or not is we're going to have to try to standardize or normalize how you measure idle power. And the process of saying how to measure it will make it clear what it is that we mean, right?
Sure.
So going back here, right, Eric, as long as we can clarify this computational includes network and storage, this is okay, right?
Maybe. I'm still not quite converted here on how we're going to do idle power versus non-idle power on the switch.
Okay.
On a compute device, right?
Right.
Non-compute system, I guess, right? Not device.
It's a system. It's depending on a switch system or how you want to measure it, right? But what I'm saying is, you could potentially say there is no idle power for switch, right? Then it basically puts everything into the, even for an example here, right? If you say there's no losses, we are basically saying 1, right? It'll go into the direction, but we need to define clearly so that idle power is really accounted there. Again, you could.
This is okay. It's when you try to, if you look at it, it kind of makes sense. But then if you think about how would I calculate this, it's like, well, what do I put in there for idle power? How do I know what to put in for idle?
So that at least if we say it's during boot, we are going to get the thing before nothing is getting loaded. And
but that means there is idle power for a switch then.
Correct,
right?
correct.
And it's most of the power. Right? 80% of the peak power is going to be there when it's booted.
All right. When you turn on all your ports, right? Yeah.
Yep. Right. If there's a cable plugged in, it'll bring up all the ports.
Correct.
So if there's any data to process, any packets to process or not, right?
Correct. then you're
For
really
most switch implementations I've seen, right, you're going to be 75, 80% of peak power at that point. The highest power you'll ever measure at the switch, you're 75, 80% of the way there once all the ports are up.
right. You're actively all the memory, everything is warmed, and you're
the
into
control
that.
plane processors up, all the links that are connected are running at full speed. Right. There is, I don't know of any switches in production today that downshift the port speeds.
You're already in the maximum rate, right? Yeah. Then I think we need to see we need to have some little further in-depth discussion on switch to define what is the idle power.
Right, and until we do that,
yeah.
you can't do a rack level example because racks have switches in them.
Right, yeah.
So the way it is right now would essentially just mean that, it's counting for 0 idle switch power. Is that, do we see a problem with that?
Yeah. How do you, so now we're going to make rules for switches that are different than the rules for compute server, right? It's just how are we going to define what idle power means and how you measure it?
Right. I mean, we are just defining how do you measure the idle power. And for switches, it may imply that it sort of considers all the power as active power and 0 as idle power. But we are just defining how to measure the idle power, right? We are not making rules separately for switches or for something else.
Yeah, I think that's what I think Eric is saying, right? If you say switches idle power is 0, then you're saying compute, why are we deviating for compute, right?
But we are
need to be consistent across the board.
Right, but we are not particularly saying that the idle power of switch is 0 or not 0, or what is compute's idle power or any other component's idle power. We are not particularly saying any of that, right? We are just defining when or how to measure the idle power.
But when you do the system IUE for the switch, right, then if the, what do you call, when it is a
you mean
idle,
system IUE where the system includes the switch?
Correct. No, just as IUE of a system, if you IUE of a network, right, network system, is it going to be much lower when it is operating in a 10% or 40%, 50% workload or traffic, right? That is going to be concern if you are
IUE for a network system will still not be 0 because it's not one single switch, right? That's not like the only.
No. So when it is a system is operating as a rack, I mean, all the systems, you are going to say like even the network switch as a system, right? That's how the what do you call the red face is describing. You have a rack, any element is chassis, and any element is a system. The type of system is network. Type of system can be compute.
Right.
Right. So when if you take a network system, and when I say network system, it's a network switch.
But okay, that's probably where when you say a network system, you're thinking of a single network switch.
Correct.
Okay, I guess that is the difference in understanding.
So you can think of top of rack switch, right?
What are you thinking of, Shruti?
I mean, essentially, I'm thinking of a system as, the compute storage and the network that is within that level of the system defined.
But network is a separate box, right?
Yes, but you are sort of thinking that this would be done for that TOR or for that switch separately.
And that's because of the way we did the example, right? So if we do this for a rack-mounted compute server, right, that one modular server, and then you try to sum up those values to do the rack, like we showed in the example, then you need something to plug in for everything in the rack,
right?
Even the things that are not compute servers, right? It's this equation that's problematic, right? This equation implies that you need some number to use for the switch rack mounted unit too, not just for the compute rack mounted units.
So that's why you need to do it separately on TOR.
Well, it implies that you have done that, so I jumped into how did we do that, right?
I think it will work. I think the formula will work as long as the network systems IUE is defined, and if you multiply IUE into server power, it's nothing but
This will
computancy
work
power.
as long as everything in the rack has an IUE,
Correct,
right? So,
correct,
so that
correct.
when you add it up, so that the right one actually does match the middle one, right?
Correct, correct.
So at that point, when you do it on Tor, it will basically just show you no idle power for it. But is that throwing off your calculation in any way?
It's not throwing off. I think argument is how are you going to calculate idle power for a switch? If we apply the CPU systems idle power metrics, is it going to work for them, right?
And a rack with dedicated storage targets in it is going to have a similar issue, right?
Yeah, but I think our way of measuring idles has to be identical across the components in a rack or within a system, right? The entire system is put in so and so state where it is actually loaded with the profile, etc., but is not actively doing any workload. So however we define that, and that has to apply to every component in the system.
Yeah. So maybe there's opportunity here, Eric. Today, the way it's operating is everything is powered up, even there's no traffic, right? But if it can go in a way where only when traffic is flowing through that switch ports need to be powered. Then it brings efficiency, right?
Right. Yeah. And we've seen, well, I don't know. I've been around a long time. I've seen proposals like RAID versus MAID, right? I don't know if you guys have read any of those papers, right? You certainly can, even for a high capacity target with disks in it, you could spin down the disks. The problem is, of course, they have to spin up and stabilize before you can get data off of them. And so now your access latency's gone to be a big multimodal number. So people typically don't do that.
But it's a disk versus you could have a memory based storage, or you can have a NAND based storage. It's different classes there, right?
Yeah, but we haven't talked about workloads yet, right? It's very difficult if you're going to do an in-memory cache like a memcached or a Redis memtier kind of an implementation, right? Where the storage in air quotes is DRAM storage on behalf of some other server somewhere else across the network. It's pretty hard to differentiate that configured server from a compute server, right? You don't know what application it's running. I don't think we're going to get that granular, are we? Where for every different class of work, you have a different IUE calculation, right? That's going to get us in trouble. Right.
Right.
What I've seen in other forums, right? We're not the only ones talking about this here in OCP, right? there are other consortia talking about IT side efficiency, and the typical approach that has been taken, right, is to apply this kind of methodology to the compute servers, things that have high power CPUs as part of the active devices, right? Not everybody, or actually a very few groups have contended much with accelerator devices, right, where there's a high power device that's not the CPU, but that is an acknowledged thing that needs to be contended with in all contexts. Most everybody else is like writing off the dedicated and other IT equipment that's not compute equipment, right? They're applying this kind of methodology only to the compute equipment, things with high power CPUs in them. Right. And you still need to get to rack totals and data center totals, but not by trying to apply this same methodology to non-compute devices or non-compute systems. Now, we can take a different tact here, right? I'm not saying that that's the only way to do it or this way can't work, but I'm still a little on the fence about whether we want to try to apply this kind of policy to a network switch.
Yeah, I think the question is how are you going to compute idle, right? As long as that is clearly defined, is there any difference between CPU versus a network? There's a concept wise we can still say.
Yeah, the conversion losses and thermal losses, no argument, right? It's just a matter of, I also am concerned about trying to, I don't think we can do idle the same way, and I don't think we can do utilization the same way.
Right.
And part of the issue there is trying to do a live continuous tracking of network utilization is pretty invasive, right?
Yeah, what is the performance when we are kind of talking about performance thing, right? Compute CPU performance or accelerator performance versus network is going to be totally different metrics, right?
Yeah, well, you think about a 96 port switch ASIC, like Tomahawk, right? With 100 gigabit ports, it's got a 0.96 terabit peak throughput. Are we going to measure utilization in terms of how much of 0.96 terabits is actually used for packets, or used for payloads, or used for utilization on a switch is a tricky thing, right? I don't know if there's any utility in us getting into that mess.
So I think what we'll do is we can acknowledge that is an area that we need to work on. Then probably we need to come back and do a little bit more work on each subsystem and clarify it, right?
And the implication of that is we're not gonna be able to do this example on the bottom of the slide. Right. Where we have a bunch of IUEs for everything in the rack, so when you sum them all up, you get a rack level total, right? It's not clear if you just do the compute systems, then you have to add the switches on top, right? There's another term that's not IUE derived for the total rack power.
Yeah.
So how you do racks is going to depend on how we resolve this discussion, right?
Correct. Yeah. I will make a note and acknowledge that and put a note here. And the same way, if you are looking at the DCA side, right? I'm basically like similar formula where the rack level computational power versus active power, and it applies for same thing for if you use rack level IUE.
Right. Yeah. No, I see what you did, and I know why you did it. I think we do, I think, want to go down a path where you could do a total at a rack level and a total at a data center level somehow.
Right.
It's just a matter of whether we do that by calculating IUE for everything and summing them all up, or we do it some other way.
Right. I think when you do the last formula here, right? I know what is IT's energy consumed. If I know all the IT's computational power, and if I know IE of IT, I can even get a PUE, right?
Yeah, that I don't think we want to do. We want to leave PUE alone.
Right? No, what is the relationship between IUE and PUE? I think this is what it brings.
Right, yeah, and we talked about that, whether you get a total by multiplying by PUE or dividing by PUE. Right? We can show that.
Right. Yeah.
So what we are saying is normally divided by this computational power by introducing IUE. We are saying it's not 100% you can account, right? You're probably accounting 90% or 80% rather than 100%, right? That's what it kind of meaning, right? Because this black box, non-compute, how much it's going to consume. Today, the whole thing is 1. You're considering this as a 1. Because of we are taking away a non-compute portion, the 1 becomes less than 1, right? That's what we are trying to convey.
Yeah, although, I mean, I think the formula is actually technically correct, but you're not making a number smaller than 1. You're making a number bigger than 1 because you're dividing by a number smaller.
Right. Because the goal is to drive to unity. That way, you're more efficient, more accuracy as far as measurements is concerned compared to the traditional PU, which is being published, without any backend data. Right. That's the goal.
Yeah, we are saying even though we are trending towards 1. Actually, reality is not really trending towards 1, right? It's still
doing this further subdivides thing, right? I think this is also hard to grok, right? And I'm not sure it helps us to pull the audience through that knothole. It may be better to just show a total. That IUE is an efficiency, and then a total efficiency where you divide IUE by PUE, right, to get the rest of the data for overhead. That's probably easier to understand and more useful.
I can say PU divided by IUE, right?
Really, right? You'd say IUE divided by PUE, right? To get a total efficiency, right? You're already below 1. You get further below 1 when you take PUE out of it.
Okay,
Mhm.
got it. Good.
The way I think the good way to is to show the merits of IUE, which is very required, right? So that way there is a, better definition, right? So, and they can walk through these examples, right? So that way they'll latch on to the concepts.
Okay,
Right.
good.
Right. Yeah. I think we want to be easy to follow, I think is your point. Yeah.
Yeah. Mm-hmm.
Where it's clear what we're doing and why that's a useful thing to do.
Yeah, exactly. What is the merit of doing it?
Yeah,
Right. So
the
that way.
examples are useful for that. We just have to be careful which examples we use if we haven't fully defined the methodology yet.
Sure. Yeah, definitely. Yeah.
Hey, I have to drop off, but just one very quick thing, Sammy, not related to this, but if you saw TCF sustainability folks sent us, what's their metrics list, the top level list of all metrics, sustainability metrics. Would you be, starting a first draft for the sustainability profile, highest, upper level that you wanted to go about?
So that is next thing I want to have a discussion today.
Okay. I'll probably have to jump right now, but I just wanted to say, like, once we can have a very initial draft, we probably want to cross-check that we are saying the same as, what they put in the form of a list. And if there are some differences, we can, arrange a call with them and figure out, because I just want to make sure two different streams from OCP are not putting out two different things.
No, at least as far as I looked at the data, it is not doing two different things. Even all the Jeff's work, I looked at it. In fact, I comprehended here. It is right now, it's a separate thing. We need to bring it together. That's why I basically like the IUE profile, or not sustainability profile when we talk about it. One thing I want to get a clarification from this team or even carbon side, right? Are we even going to report a carbon capability or not, right? Embedded carbon. I think all the work what I have done is, as long as you report this chassis and manufacturing version number, serial number, everything, somebody outside the data center, they will go and figure it out. It is not a system's responsibility.
So
that is one way of saying.
Carbon point that you were asking is, see, we are already working on what is sort of like a label format or a disclosure format for carbon, because just putting a carbon number does not suffice. It needs other context to be put. So what we could do is have carbon label separate, but make this from a sustainability power profile point of view.
Yeah, that's where I'm trying to use that as an example. When we say sustainability profile, is this a two thing, or do we want to add something else on a system level? So this is, at the end of the day, what we are trying to describe is, I think I didn't go through all the materials here. We are trying to describe what is the BMC need to provide and what is the rack manager need to provide. Because you can think of data center is constructed based on systems and racks, right? And there are additional components which we are not describing as a red piece component that is coming as a data center facility or group, right? That is data center level. So if we take a system level, these are the two things that is coming out of the system, at least my understanding so far.
Sure. Yeah.
Right.
In order to list the items, yes, those are probably the two things or the two sides.
Correct. So
yeah, I think there's some ambiguity here, though, right? Where like you wouldn't ask someone to have in a prom somewhere what the carbon intensity of the energy is. Clearly, that wouldn't work, right? So when you try to do the full sustainability profile, you can get the energy from the system hardware through a Redfish API, right? You cannot get the carbon intensity that way. You have to get the contemporary carbon intensity has to be provided some other way through a different interface at runtime.
There's two carbon, right? It's operational carbon and
the same thing is probably true of the embodied carbon.
Oh,
right?
it's even worse for embodied carbon. You cannot.
Yeah,
It's
that's
getting
where I'm headed, right? I think this
Yeah.
idea that you have to be able to interrogate the hardware to find out it's embodied carbon, that's probably not right. You have to
Yeah.
interrogate the hardware to find out what hardware you have, and then some other interface you look up those devices to get their embodied carbon.
So that's where, right? Embedded
Yes.
carbon, what we are saying is get through information. If
Right.
that is mandatory. If you, as long as you get a full information, then you can go back and look at whatever the data sets to say like what is your embedded carbon, right?
Right. I'm just saying that may not be a BMC or a rack manager thing, right? That may be a higher level API.
No. Today we have the chassis and serial numbers as a baseline profile for systems.
Yep. Yeah. So the fruit, no arguing about fruit information.
Right.
Carbon for them. Like we don't have the embodied carbon for them.
Yeah. I don't think we want to require that devices somehow know their embodied carbon. I think that's a bad idea.
Yeah, I think we should not make that assumption. We are not, at least if that's going to happen in the future, we are certainly very far from that. And plus, like I was saying, embodied carbon can't just be stated as a number. It needs other context of how it was, measured, etc., which is quite detailed, which is actually why they are doing an entire label for it.
Yeah. So there's two ways of representing it, right? You can say in the capability, that's the reason I put capabilities, right? Capability say I'm not reporting embedded carbon, but I'm reporting only full information. That is one way of doing the implementation, right?
Yeah, I think the reason we're having this discussion is it's implied that there's some future date where you can get the embodied carbon. I'm not sure that's the case.
Yeah,
okay.
I don't think that's a good thing to pursue.
Yeah,
okay.
Definitely.
So
yeah.
then I think what we can do is we can say embedded carbon related hardware information, just leave it there. And we can just go with the IUE. And if you want to provide a IUE portion, but I basically put all these things, right, related to some of things we are discussing. Power, ideal power, and power loss and cooling, all those things becomes mandatory. What I'm saying is if PSC is present, you need to report that number. If ERs are present, you need to report the number. Fans present, you need to report the number. And ideal, I am putting the number here. I think that need to be reported.
Yeah. How does that get set? We have a whole future
we need to discuss, right? That's next level of details. But
yeah, this portion makes sense. We need to discuss more details. For this part, I would also, see if Danny can join your work stream or you folks can join his work stream sometime.
Yeah. We will go there. But before going there, I want to get the alignment here within the thing, right? Is this make sense, right? Then we can go to Danny and say like, hey, can you give me the information? In fact, there is one more thing, right? When I go to the rack level, I want to even have the PSU sharing boundary and redundancy, fan sharing boundary and CDU sharing boundary and everything, right? And I think we are also at the top of the hour. I can send it out. Let us do the review, and if we can align, probably we can have the discussion next week.
Sure.
And if we are aligned, then we can go to the Danny's work group and say like, hey, I need these additional things. Can you add it to your list, right?
Yeah,
okay.
Sounds good.
Yeah, I think this portion is making sense. Let's talk about this next week.
Okay. Very good. Okay.
Thanks,
Thank
Sammy.
you, Tim.
Yeah.
We'll see
Thank
you.
you.